Related to the determinant of a matrix are these things called minors and cofactors. This is going to take a little bit of attention to detail, and it's also going to be a little difficult because usually I can do this like pointing at a whiteboard, but I'm going to do my best. So minors and cofactors of a square matrix. So say A is a square matrix, so maybe it's a 2 by 2, a 3 by 3, whatever, something as long as the rows and columns have the same value. The minor M sub ij of the entry A sub ij is the determinant of the matrix obtained by deleting the ith row and the jth column of A. Yikes. We're going to come back to that. The other definition in here is the cofactor. The cofactor C sub ij is of the entry A sub ij is C sub ij equals -1 raised to the ij power times M sub ij. Oh my goodness. We're going to take this slowly. So when finding the minors and cofactors, it's important to note that whether it will be positive or negative. So we're going to say odd positions. So that means if it's I plus j, the row plus column gives you an odd number, you're going to have opposite signs. In other words, C sub ij is going to be -1 times your minor. Again, what the heck? We'll figure this out in a second. And then if it has even positions, so if I plus j adds up to an even number, you keep the sign. So the cofactor and the minor would have the same sign. Now, looking at this, we're asked to find all the minors and cofactors of this matrix A. We're going to start with the minors. So for this, we're going to start off with M sub 1, 1. And the way I think about it is I'm going to cross off row 1 and column 1. Now I'm putting this in quotes because we still want to use those values. So like I'm gonna physically cross them off here just to kind of demonstrate where I'm getting these numbers. So M sub 1, 1. Essentially, we got to pretend, and again, don't do this because you're going to need these numbers eventually, but it's as if that row 1 and that column 1 gets crossed off. So what we're going to do is we're going to take the determinant of that remaining piece, essentially this matrix right here. So we're going to have -1, 2, 0, 1. So we're going to take the determinant of that remaining matrix. So we're going to have, going in that same pattern we looked at on the previous page, it'll be -1 times 1 minus 0 times 2. So -1 times 1 is -1, minus 0 gives us -1. So our minor for M sub 1, 1 is -1. Now I'm typically not going to write that much work for every one of these, but for this first one I figured better safe than sorry. So now M sub 1, 2, let me switch colors so we don't get things mixed up. M sub 1, 2 is as if we're crossing off row 1 and column 2. And the matrix we're left with there is that 3, 2, 1, 4, or sorry, 4, 1. So we're going to have 3 times 1, so top left times bottom right, minus 4 times 2, which gives us 3 minus 8, which gives us -5. Carrying on, again, when I'm doing these on the board, I accidentally erased a little too much. I typically just kind of like put my arms over these, so like as if I'll be like, okay, we're canceling that row off, but it's still there. So it's like cancel that row, cancel that column, whichever one. So M sub 1, 3 is going to be crossing off that first row in that third column. So essentially we're left with the 3, -1, 4, 0. So focusing on this little area here, it's going to be 3 times 0 minus 4 times -1. So we have 0 plus 4, which gives us a minor of 4. Folks, we just finished the row 1. Now we got to do row 2. So there's a bit more work we got to do here. So we got M sub 2, 1. So again, it's as if now we're crossing off row 2, canceling that one off, and column 1. So let me physically do that for a second. So we're canceling off row 2 and column 1, and we're using those numbers that are left that are not canceled out. So of the numbers that are left, the top left is 2, multiplying it by the lower right is 1, minus lower left is 0, times 1. Which, when we clear that up, we got 2 minus 0, which gives us 2. Moving on to m sub 2, 2. We're essentially crossing off row 2 and column 2. So, using the numbers we have left there, we got 0 times 1 minus 4 times 1. So we got 0 minus 4, which gives us negative 4. And then for the final one in that row, we're going to cross off row 2 and column 3. So we got m sub 2, 3. We're left with 0 times 0, not too bad, minus 4 times 2. So we have 0 minus 8, which gives us negative 8. Okay, we are on to the final row. So, moving on to the final row, we're going to do m sub 3, 1. So crossing off row 3, column 1, we're left with that matrix of like 2, 1, negative 1, 2. So we're going to have 2 times 2 minus negative 1 times 1. So we got 4 plus 1, which gives us 5. All right, m sub 3, 2. So, oops, sorry, writing utensil. M sub 3, 2. So effectively, it's as if we're crossing off row 3 and column 2. Looking at those numbers, we got 0 times 2 minus 3 times 1. So we got 0 minus 3, which gives us negative 3. And our final minor, it's m sub 3, 3. So essentially ignoring row 3 and column 3. So we have 0 times negative 1. Oh, sorry, I kind of jammed myself, or kind of put myself in a corner there. Let me shift this over just a little bit. So we got 0 times negative 1 minus 3 times 2. So we have 0 minus 6, which gives us negative 6. So those are all of our minors. Now the cofactors, we have a little bit more work to do. But thankfully the cofactors aren't that bad, to be honest. So cofactors, we're going to start off with c sub 1, 1. So kind of going off of what we had, and I'm going to erase what I wrote on this matrix here. So it's going to be negative 1 to the I plus j power times the minor there. So in this case, it'll be negative 1 raised to the 1 plus 1 power times the minor at 1, 1. So negative 1 to the 1 plus 1 is negative 1 squared, which is just 1. And then m sub 1, 1, we ended up having a negative 1. So it's 1 times negative 1, which means our cofactor is negative 1. Now going back to what we said earlier, even positions where they add up have the same sign. Odd positions have the opposite sign. So looking at the next one, it'll be c sub 1, 2. It's going to be the opposite because 1 plus 2 is 3 times the minor at 1, 2, which was negative 5. So we end up with positive 5. Sorry, let me color code that because I was color coding it earlier. Now c sub 1, 3. That's an even position, so it's going to keep the same sign as the minor at 1, 3, so it's just going to be 4. C sub 2, 1. So row 2, column 1, that was up here. It was a positive 2, but 2 plus 1 is an odd number, so it's going to be the opposite sign. So C sub 1, 2 is going to be the opposite, negative 2. C sub 2, 2, that's an even position because 2 plus 2 gives us 4. So it's going to keep the same sign as the minor, and the minor at 2, 2 was negative 4. So it's just going to stay at negative 4. C sub 2, 3, that's an odd position because 2 plus 3 gives us 5. So it's going to be the opposite sign of the minor at 2, 3. So it's going to be the opposite of negative 8, which gives us positive 8. Final row, m sub 3, 1. 3 plus 1 is an even 4. So it's going to keep the same sign as the minor, so it's going to be staying at positive 5. C sub 3, 2, row 3, column 2. 3 plus 2 is 5, so it's an odd number, so it's going to be opposite. So it's going to be opposite sign of that negative 3, so that's going to give us a positive 3. And finally, C sub 3, 3. We're going to get 3 plus 3 is an even number. It's an even 6. So we're going to keep the sign of our minor, so it's going to stay as a negative 6. Whew, that's a lot of work. If you're at home, take a break.